This video is the next video in the function set of videos. In particular, this is looking at section 9 of the notes, which is all about graphing exponential functions. So functions which have a variable in the power are called exponential functions. So for example, you would have f of x equal to 2 to the power of x is an exponential function. So anything, so if we had 3 to the power of x, or 2 to the power of 3x plus 1, or 5 to the power of 3y plus 2, they're all exponential functions. When graphed, these functions will have shapes similar to a skateboard ramp. You can see there that I have f of x is equal to 2 to the power of x drawn on the page in front of us. So what we need to be able to do is to draw these types of graphs, but it's very similar to how we would have drawn linear, quadratic and cubic functions. Question 9.1 says graph the function f of x is equal to 4 times 2 to the power of x between minus 4 and 1, where x is an element of OR, and OR stands for real numbers, and I'm hoping you can remember real numbers are any number. To start this question then, we draw our table. So on the left hand side we have our x's, and they go from minus 4 up to 1. And then in the center we have our function, which is 4, 2 to the power of x, and on the right we have the y. So filling in the center, this becomes 4, 2 to the minus 4, 4, 2 to the minus 3. Now when we fill in x is equal to minus 4, we get an answer of a quarter. When we fill in minus 3, we get the answer of a half. When we fill in minus 2, we're going to get the answer of 1. When we fill in minus 1, we're going to get the answer of 2. When we fill in 0, we're going to get the answer of 4. And when we fill in 1, we're going to get the answer of 8. The next thing we need to do is draw our x and y axes, and you should get something similar to this. So all you have to do then is plot your points. So we can write out the points to make our lives a little bit easier. We have minus 4 a quarter, minus 3 a half, minus 2 1, minus 1 2, 0 4, and 1 8. Plotting those points then, we have minus 4 a quarter, so that would be approximately here. We have minus 3 a half, approximately here, minus 2 1, minus 1 2, 0 4, and 1 8. So something similar to that, and then you just join them together. And that is the function complete. So you can then write that this is f of x equal to 4 times 2 to the power of x. And that's this question complete. There is one thing you really need to note about exponential functions, and that is where they cross the y-axis. And if you think of the graph that we had in the last slide, it crossed the y-axis at y is equal to 4. However, this is no coincidence. The graph will always cut the y-axis at whatever number the function is multiplied. So for example, if we had 7 times 2 to the power of x, it would cross at y is equal to 7. If we had minus 8 times 2 to the power of x, it would cross at y is equal to minus 8. 2 to the power of x would cross at y is equal to 1, because 2 to the power of x is the same as 1 multiplied by 2 to the power of x, and so on. If I were asked to find f of minus 2 in the last question, it would want us to find the height of the graph at x equals to 2, so the answer would be 1. Similarly, f of minus 3 is equal to half, and f is minus 1 is equal to 2, and so on. Again, hopefully this will make more sense when we do a few questions and we're talking about it in detail, but the main thing to note is when we have a function, f of x, and it's an exponential function, so any 2 to the power of x, if there is a number in front of that, so we have multiplied by 6, it's going to cross the y-axis at y is equal to 6. Question 9.2 first of all asks us to sketch the graph of f of x is equal to 3 to the power of x in the domain between minus 2 and 2 for x, where x is an element of OR, and of course we know that OR is a real number, and real numbers are any number. The first thing we do, as always, is create our table. We have our x on the left, we have our function in the middle, and our y on the right. So our x this time is between -2 and 2. Our function then is 3 to the power of x, so 3 to the power of -2, 3 to the power of -1, 3 to the power of 0, 3 to the power of 1, 3 to the power of 2. Filling this in, we're going to get, for -2, we're going to get a ninth. For -1, we're going to get a third. For 0, we're going to get 1. For 1, we're going to get 3. And for 2, we're going to get 9. So the points we have then, -2, 1 over 9, -1, a third, 0, 1, 1, 3, and 2, 9. Once we have our table and our points, we can make an x and y axis, like the one here. When we've got that drawn, we just then need to plot our points. So we have -2, a ninth. It's going to be down here. -1, a third. It's going to be here. 0, 1, 1, 3, and 2, 9. So we draw that there, and then we just join the points together. When you do join it together, you should get something similar to this. Now, so that's the first part done. So I can label this here as A, and we'll do B here. It says, where is f of x equal to 9? Now, we know that f of x is the same as y, so we're looking where y is equal to 9. All we do there is we go across on the y-axis at 9, and we figure out what it is, and then we come down on the x-axis, and we figure out that it's 2. So all we have to write here is x is equal to 2. And that's the answer for part B. That brings this video to a close then. I'm hoping that you feel confident enough now to try drawing your own exponential functions. If you have any questions, get in contact with me, but I hope the questions you're going to do will be fine now.